Welcome back to the deep dive. Today we are plunging into, well, this communication superhighway that researchers really believe defines so much of human wellness.
We are indeed. It's that bidirectional connection between your gut and your central nervous system.
We're talking about the microbial world inside you, right?
Exactly. And it's an area of research that just keeps, fundamentally shifting how we understand health. We're really moving beyond seeing the gut microbiome as just something that digests food.
Right.
It's increasingly recognized as this invisible organ. That's a great way to put it. It communicates directly with the brain, influencing, well, everything from mood to resilience.
And even how quickly your brain ages.
Critically, yes.
How quickly.
Your brain ages.
So that's a mission today, then. We're synthesizing sources focusing on three key areas. First, we need to understand this, frankly, kind of shocking link between gut health and accelerated brain aging in older adults. Second, let's dissect the chemical language, the neurotransmitters, basically, that let this conversation happen nonstop.
Yeah, the messengers.
And third, we'll look at the real-world promise, maybe, of targeted interventions, specifically things like psychobiotics for, common issues like sleep problems and mood disturbances.
Okay. So to start, we really have to frame the gut-brain axis properly, the GBA. Think of it less like a simple cable and more like a dynamic, absolutely critical communication infrastructure. It links the enteric nervous system, that's your gut's nervous system, sometimes called the second brain.
Right, the second brain.
To the central nervous system.
Okay, but when we talk about communication between two, very different organs, like the gut and the brain, it can't just be nerves running the whole way, can it? How do they actually talk to each other? What are the pathways?
That's a great question. It's really a multi-channel system. We can break it down into four main routes.
Okay.
First, there's the neural route. That's the fastest one. Think of the vagus nerve acting like a dedicated high-speed fiber optic highway directly connecting the two.
Wow, okay. High speed.
Then second, you've got the endocrine route. This uses hormones traveling through the bloodstream. So it's more like the body's postal service. Good for longer-term messaging.
Okay, hormones like the mail. And what about the others? You hear so much about inflammation these days. Does that play a role?
It absolutely does. That brings us to the immune route. See, gut bacteria are constantly interacting with immune cells that line the gut wall.
Right.
And this generates signals, things like inflammatory factors, or maybe anti-inflammatory ones, that then circulate through the body and directly affect brain function. You can think of this as the body's security system reporting up to headquarters in the brain.
Interesting analogy. And the last one?
The last one is, maybe the most fascinating, is the humoral route. This is communication through thousands of tiny metabolites. Basically a chemical soup.
Produced by the microbes themselves?
Yeah. Exactly. Produced by the microbes, which then enter the bloodstream, and some can even cross the blood-brain barrier. So the health of this entire axis, the clarity of all this messaging across all four channels, it really depends entirely on the composition of that, trillion-strong microbial community living inside you.
Okay, let's unpack this then, using that first key finding from our sources. The one dealing with physical, measurable aging. We need to talk about brain age. For anyone listening who's maybe new to this, what exactly is this measure? What does it tell us?
Right, so brain age is a pretty sophisticated biomarker. It's calculated using neuroimaging, usually MRI scans, to assess the physical state of the brain's gray matter.
Okay.
It essentially boils down to a single number that reflects the cumulative toll of, well, everything, environmental stressors, genetics, neurodegeneration over time. But the key insight we really need to focus on here is the brain age residual.
The residual. So if your residual is high, that means your brain actually looks older than it should based on, your driver's license, your birth certificate.
That's exactly right. Perfect analogy. Imagine you have a 5-year-old sports car, but maybe you haven't maintained it well.
Right.
Its engine looks and performs like it belongs to a 10-year-old clunker.
Right.
That difference, that 5-year gap, that's your residual. A high positive residual indicates accelerated aging of the physical brain structure. And research has shown again and again, this is a strong predictor of future cognitive decline.
Which brings us to that core finding from the big study in South Korea. They followed nearly 300 people in memory clinics, and they linked the gut microbes directly to this physical aging measurement. What did they actually prove? What was the connection?
Okay, so they established what's called a mediated relationship. And this is where the discovery really lies.
It's mediated.
Yeah. They found that participants who had greater gut microbiome dysbiosis, basically, a bad imbalance in their microbes.
Okay.
They also had worse cognitive function scores, measured by standard tests. But here's the critical link. This negative impact on cognition was partially mediated by greater brain age.
Wait, let me just make sure I'm following the chain of events they're suggesting here. It's not just It's not simply that bad gut health and bad cognition happen together.
No.
They're saying the gut imbalance seems to lead to the accelerated physical aging of the brain's gray matter, and that faster aging is what's directly driving the cognitive decline they observed.
That is precisely the implication, and it really shifts the whole paradigm, doesn't it?
It really does.
The gut community isn't just sending temporary chemical signals that maybe make you feel a bit foggy for a day. It appears to be actively participating in, and potentially even driving, the physical structural degradation we normally associate with age-related decline. The dysbiosis is, to use your analogy, making the car look like a clunker prematurely.
Okay, so who are the culprits then? What did this group, the ones with the high brain age residual and the poor cognitive scores, what the study called Cluster 2, what did their gut actually look like under the microscope?
Yeah, so Cluster 2 showed a really definitive shift in their microbial profile. They had lower proportion of beneficial phyla, most notably one called firmicutes.
Firmicutes, okay.
You can think of firmicutes as like the highly efficient beneficial workers in the gut factory. They're really good at generating things like short-chain fatty acids, which are crucial fuel for the gut lining and help regulate immune function.
So less of the good guys and more of...
Conversely, yes, this cluster showed higher proportions of groups generally identified as potentially detrimental or maybe pro-inflammatory. These included phyla like Bacteroidota, Proteobacteria, and microbiota.
So the efficient workers are down and groups linked to inflammation and maybe less useful processes are up. Did this study manage to drill down even further, like to a specific type of bacteria strongly linked to the brain aging?
It did, actually. In what they called an exploratory linear regression analysis, one specific family, Bacteroideaceae, which falls under that Bacteroidota phylum, showed a significant statistical association with greater brain age. So the evidence is getting more and more granular. It suggests the specific composition of this microbial community has a tangible, measurable influence on the structural integrity and indeed the aging rate of your brain.
Wow. This just raises the absolutely essential question then. How? How does a family of bacteria living way down in your intestines communicate all the way up to the gray matter in your skull to cause this kind of systemic change? The answer, like you alluded to, has to be chemical, right? A chemical vocabulary.
Absolutely. The gut microbiome is essentially a massive pharmaceutical lab. It's constantly producing neuroactive metabolites. That includes neurotransmitters themselves and also their crucial precursors. And the scale. The scale is just difficult to really grasp.
Okay, let's talk scale then. You mentioned serotonin earlier, probably the most famous feel-good neurotransmitter.
Right. Serotonin, or 5-HT, it's absolutely critical for modulating mood, behavior, sleep, you name it. And the estimates are that something like 90 to 95% of the body's entire supply is synthesized right there in the gut.
90 to 95%. That's staggering. It means the vast majority of our primary mood regulator is made by, or at least heavily influenced by, the bacteria living inside us. So what happens to serotonin production when that gut environment shifts towards dysbiosis, like in cluster 2?
Well, it seems to come down to an amino acid called tryptophan. Tryptophan is the essential precursor, the building block for serotonin.
Okay.
When the gut is healthy, tryptophan is efficiently channeled towards making 5-HT. But when dysbiosis occurs, especially if you have higher levels of certain pro-inflammatory bacteria, tryptophan metabolism gets shunted down a different path. It's called the kynurenine pathway.
So it's like a fork in the road and the signpost to serotonin gets blocked.
That's a perfect way to put it, exactly. This diversion steers tryptophan away from making the feel-good molecule and towards producing metabolites that are actually pro-inflammatory and can cross the blood-brain barrier. So this diversion of resources is strongly linked in research to increase risks of depression and anxiety, because the brain is suddenly, potentially, starved of the 5-HT it needs and is maybe getting bombarded with these inflammatory byproducts instead.
Okay, that pathway makes sense for mood. What about the other key neurotransmitter you mentioned? The gut produces GABA. If serotonin is kind of the accelerator for mood, people often call GABA the brake, right?
That's a great analogy, yeah. GABA is the primary inhibitory neurotransmitter in the central nervous system. It acts as the body's ultimate checkpoint, essentially applying the brakes to neuronal excitability.
So it promotes calm?
Yeah, exactly. Relaxation, mental calmness. So when GABA levels are low, And remember, the gut is responsible for producing a substantial chunk of it. That insufficient braking powers is associated with things like anxiety disorders, chronic stress, even panic attacks. So it shows that dysbiosis doesn't just mess with one chemical system. It can throw off the entire delicate balance of both excitatory and inhibitory signals traveling along that gut-brain axis.
Given this incredibly strong and seemingly quite specific link between the state of our microbes and our central nervous system health, what happens when we try to influence this community deliberately? Let's look at using psychobiotics. That's probiotics specifically chosen for mental health benefits, right?
Precisely. And we have a very comprehensive recent systematic review and meta-analysis. That's a study that combines results from many previous studies focusing specifically on patients struggling with insomnia and often related mood disorders. And the results were actually robust enough to show clinical significance.
Okay, let's get into those specifics then. What were the actual results for sleep quality? That's often measured subjectively, right? How people feel they slept.
Yes, they looked at a common measure called the Pittsburgh Sleep Quality Index, or PSQI. It's a scale typically runs 0 to 21, where scores over 5 generally indicate poor sleep quality. The combined studies found that probiotic interventions were associated with a significant reduction in these overall sleep quality scores. They dropped by a mean difference of 2-point Dow zone points compared to the control groups. And that 2-point Dow zone points is considered clinically significant.
Right, a drop of 2 or more points on the PSQI is actually a pretty big deal in clinical practice. It often marks the difference between someone reporting chronic poor sleep and someone feeling their sleep is genuinely noticeably improved. What about mood? Did it help with the depression scores too?
It did, significantly. They used the Hamilton Depression Scale, or HAM-D. Probiotics significantly reduced those scores by a mean difference of 7.72 points.
Wow, 7.72 points. How significant is that?
Well, to put it in perspective, scores of 24 and above usually indicate severe depression. Moderate depression is often in the 17-23 range. A 7.72-point reduction can literally move patients from a clinical state of depression down into a substantially lower, less severe category. It's a therapeutic effect that honestly rivals some pharmaceutical interventions.
That sounds extremely promising. But you mentioned this was a deep dive analysis, which usually means it found limitations or caveats. Did the probiotics fix every single measure of sleep difficulty?
They did not. And this is where it gets quite interesting. The analysis noted a fascinating split. While that subjective feeling of sleep quality improved dramatically, the probiotics showed no significant effects on some of the more objective secondary sleep metrics. Things like total sleep time, sleep efficiency, that's the percentage of time in bed actually asleep, or sleep latency, which is how long it takes you to fall asleep. Those didn't really budge significantly.
Why do you think that distinction exists? Why would people feel their sleep is much better and their mood is better, but the sort of hard numbers, the time spent asleep or time to fall asleep, don't change much?
I think it points right back to the mechanisms we were just discussing, the gut-brain axis mechanisms. The primary impact of these psychobiotics might be more anti-inflammatory and stress modulating. So, by reducing the overall systemic anxiety and inflammation, which were likely the main drivers of the poor sleep quality in the first place, the patient feels calmer, more rested, generally better. Even if the actual sort of physical clockwork mechanisms governing sleep initiation, like light sensitivity or core body temperature changes, haven't really been altered.
So it's reducing the stress around sleep, which is often the biggest barrier to feeling rested.
That seems like a very plausible explanation. And importantly, the studies also show these interventions were generally safe and well tolerated, with no significant difference in adverse events compared to placebo groups.
Good to know. Okay, let's quickly recap the proposed mechanism then. How are these specific bacteria thought to achieve this calming, anti-inflammatory effect?
Well, the researchers suggest it's likely threefold, and it links directly back to our earlier discussion on the GBA pathways.
Okay.
First, certain probiotic strains, particularly those in the Lactobacilli genus, are known to enhance the synthesis of GABA. Remember GABA, the brake pedal?
Right, the inhibitory one.
So by adding more bacteria that make or promote GABA, you might be physically stepping on the central nervous system's brake pedal, helping to reduce that overall excitability and anxiety.
Makes sense. What's the second way?
Second, they seem to drive those anti-inflammatory effects we talked about. They do this by modulating the immune pathways, reducing pro-inflammatory factors like IL-6 and TNF-alpha. Calming down that inflammation helps quiet the GBA, which, when overactive, can cause things like waking up during the night.
And finally, they help manage stress directly.
Exactly. They appear to help regulate the hypothalamic pituitary adrenal axis, the HPA axis. That's the body's main stress response system. They might do this by affecting stress hormones like cortisol. So essentially, by stabilizing the gut environment, you could be helping to regulate the cascade of stress hormones that often goes hand in hand with chronic sleep deprivation and depression.
So let's pull this all together. What does this mean for us, for the listener? This deep dive seems to have shown us two really crucial things. First, the link between our gut health and measurable accelerated brain aging looks pretty undeniable. It suggests cognitive decline isn't just a brain issue, it's maybe a whole body systemic issue starting in the gut. And second, these microbial interventions, like psychobiotics, are moving out of the realm of just, speculation and showing real clinical significance for tough issues like mood and sleep problems.
I think that's a great summary. The final synthesis really becomes clear. Perhaps the most dangerous aspect of ongoing gut dysbiosis isn't just the temporary discomfort or even the immediate cognitive fogginess it might cause, but its potential role in actually accelerating the physical clock of the brain itself. And if that's true, it really mandates that future interventions aimed at preventing or slowing age-related cognitive decline must consider targeting the gut microbiome as a key strategy.
Which brings us to a really fascinating final thought for you, the listener, to consider. That meta-analysis on psychobiotics for sleep. It showed that their effectiveness actually varied quite significantly depending on the geographic source of the studies and the population being looked at.
That's right. There were very strong positive results, for instance, in cohorts from China, but maybe less significant effects seen in populations studied in Japan and South Korea.
So what does that imply?
Well, since we know for a fact that the gut microbiome is powerfully shaped by things like genetics, local diet, and cultural practices,
Right.
it strongly suggests the future isn't just about finding one universally effective probiotic strain, like a magic bullet.
Yeah.
It's much more likely about finding the right, maybe personalized psychobiotic cocktail for you, depending on your specific genetic background, your diet, your environment.
So the final question really becomes, what could further dedicated studies on these localized, culturally specific diets and the gut microbiomes that go with them reveal? What might that tell us about truly optimizing mental health and maybe even brain longevity across all the diverse populations around the world?
Exactly. It opens up a whole new avenue for personalized medicine and understanding how our environment shapes our inner world.